Hello dear students, this is Saktivel from AstraDex. Today we are going to discuss about the topic calorimetry, which is in the chapter 8 Heat and Thermodynamics, which is belongs to 11th standard state board physics. Calorimetry, it is the measurement of heat. Actually, what is called calorimetry? What is called calorimetry? So calorimetry means is the measurement of amount of heat released or absorbed by the thermodynamic system during the heat exchanging process. When the body at a higher temperature brought in contact with the body at a lower temperature, the heat will be transferred from hot body to the cold body. So in this process, the hot body lost the heat and the cold body gained the heat. Okay, mathematically, the principle of calorimetry can be written as here given in that formula, heat lost will be equal to heat gain. Actually, by the sign convention, heat loss will be taken negative symbol and heat gain, that is Q gain, will be taken positive sign by the sign convention. In this equation, if we rearrange this equation means we can get heat loss plus heat gain is equal to 0. Q refers to heat. Okay. The next one is calorimeter instrumental design. Here, calorimetry is the measurement, calorimeter is the instruments. That calorimeter actually consisting 3 main parts. One is outer container and inner calorimeter cup and reflector and insulation system. Here actually outer container made up of insulating wood and inside the insulating wood the air insulation given, air layer will be spread inside the insulating wood. So with both the insulating wood and the air insulation will provide insulation to the calorimeter. That means it prevents the heat loss to the surrounding. Okay, and inside the insulation layer, air insulation layer, that inner calorimeter cup will be placed. This is the calorimeter cup. The calorimeter cup usually made up of copper material, which is inserted inside the air insulation. Okay, and this whole arrangement will be closed by a lid. A lid provided by 2 holes. Through the one hole, that a thermometer is inserted, and through the another hole, a stirrer will be inserted. Okay, and the calorimeter cup usually placed inside the calorimeter, which is consisting its total capacity. 2/3 of capacity is filled by water, and the third part is reflector and insulation. Actually, the reflector mirror will be act as a reflector. Here, mirror will be given, and outside the mirror, that wooden insulation layer will be given. Here, that air insulation air layer and reflector, mirror reflector and wooden outer layer, all will be provide insulation. That is, it to prevent the heat loss to the surrounding. Okay, the next one is calorimeter with a sample block. See, actually, the initial temperature of the water and a sample will be measured with the help of thermometer as T1 and T2. and T2. So T1 and T2 will be the initial temperature of the water and sample. Now the sample is heated. Here this is the sample. The sample will be heated up and inserted inside the calorimeter. Okay. Now with the help of stirrer, the air and the water and the sample will be mixed together. Here only the heat exchange takes place. Here sample at a higher temperature, the water at a lower temperature. The heat will be exchanged from the sample to the water. Okay. Now the final temperature of the calorimeter can be measured with the help of thermometer. Here that heat for the sample, heat of the sample can be taken as Q1. Here Q1 is the heat of the sample, that is Q last. Q is equal to ms del T. Ms del T. Here heat of the sample will be denoted as Q1. So Q1 is equal to minus M1 S1 into del T. The minus symbol refers to heat loss by the sample. And heat gain by the water will be denoted as Q2. That will be given by the formula, that this formula from the specific heat capacity formula. So Q2 will be equal to M2 S2 into TF minus T2. Okay. Next, we can derive the equations for the final temperature from this equation from the principle of calorimeter. Heat exchange. See, as already we said, the Q lost or the Q gain will be equal to minus Q lost. Okay. Here the heat gain will be Ms, that is M2 S2 into Tf minus T1. So Tf minus T2 will be equal to minus M1 S1 Tf minus T2. So if we rearrange this equation, we can get this equation. Just multiply inside M2 S2 into Tf, that will be given here, minus M2 S2 into T2 given here is equal to minus M1 S1 into Tf, then the minus into minus plus M1 S1 into T1. Okay. If we again rearrange this equation, as here the Tf term goes to that side and the T2 term goes to this side. Okay, this goes to left side and the T2 term goes to right side. So the rearranged equation is given here: M2 S2 Tf plus M1 S1 Tf will be equal to M2 S2 T2 plus M1 S1 T1. In the LHS side, in the left hand side, Tf will be a common term. That a common term can be taken out. So Tf into M2 S2 plus M1 S1, which is equal to M2 S2 T2 plus remaining term M1 S1 T1. From this equation we need only Tf. So keeping one side Tf, another term goes to that side, means that well rearrange the equations given here. Tf is equal to M2 S2 T2 plus M1 S1 T1 whole divided by M2S2 plus M1S1. Okay, this is the required formula for the final temperature of the calorimeter. The next one is, based on this above equation, example problem given here, example 8.7. What is the problem given here? Read the problem. See, if 5 liter of water at 50 degrees Celsius is mixed with 4 liter of water at 30 degrees Celsius, what will be the final temperature of the water? Here, the specific heat capacity of the water is given as 4184 joule per kg per Kelvin. First of all, we have to take given data. What is given data? M1 will be 5 liter. M1 is equal to 5 liter, which is equal to 5 kg. And M2 will be a 4 liter of water, which is equal to 4 kg. And S1, S2 will be the same because water and the sample also water. So S1, S2 will be equal to S. And T1, that is initial temperature of the water, will be 50 degrees Celsius, which is equal to, in the Kelvin scale. So if we add 50 plus 273 means that our initial temperature of the water will be 323 Kelvin. Like that, sample also water at 30 degrees Celsius. If we convert into Kelvin, 303 Kelvin. What is the formula used for this final temperature of the calorimeter? TF will be equal to M1 S1 T1 plus M2 S2 T2 whole divided by M1 S1 plus M2 S2. Here, instead of S1 and S2, we have taken S. Okay. Then we have to substitute. Next step is substitute the given data in this equation. Here S is the common term in the LHS side, and also RHS side also S will be common term. So S will be cancelled out. In the remaining term, you have to substitute. For M1 5, for T1 323 Kelvin plus 4, that is mass M2 is a 4 kg, into T2 will be the 303 Kelvin whole divided by M1 5 kg plus M2 4 kg. Okay, just if you multiply this two terms and add it, we can get 3141.11 whole divided by 4 plus 5 plus 4 9. Just it is approximated value, that 9 will be rounded off and it will be divided by 10, means we can get 314.11 Kelvin. So 314.11 minus 273 means we can convert this temperature into Celsius scale. So that the final answer will be a 41 degrees Celsius in the Kelvin scale, 314.11 Kelvin. Okay. The next one is summary. Calorimetry, summary and concepts. First of all, definition is given. Calorimeter means what? Already I said that calorimeter is a measurement of the heat energy released or absorbed in the thermodynamic system. And the final equation we derived, TF equation is given. And fundamental principle that also already we discussed, that is heat loss will be equal to heat gain. Actually, heat gain will be taken as positive and heat loss will be taken as negative by the sign convention. That only given in the next one. Okay. Next, applications. What are the application of the calorimetry? So temperature measurement of the various thermodynamic system is done by calorimetry. And energy calculations in the chemical reactions will be done by the calorimetry. And fuel calorific value determination is done by calorimetry. And heat capacity of the various material can be determined with the help of calorimetry. Okay, that's all. Thank you everyone. Let us stay with AstraDex. Thank you.